Good morning, guys. Today in math, you are going to need the following items. So to start off, like we do every day, we're going to be working on our simple solutions. After simple solutions, we are going to fill in 2 more terms from our geometry paper. And to wrap up, we are going to do 2 lessons from Eureka. So right now, all you need is your simple solutions packets. Okay, so get that out and ready to go. We're on lesson 86, which you did for morning work today. Let's see some of the questions that I think were a little troubling. So the questions that I think would have given us a little bit of a hard time today, I circled 3, 4, 11, 12, and 14. So if you have additional questions that I do not answer during this math block, but you would like to know how to solve them, I will be available this afternoon to help you out on that. So starting with number 3, I'm going to do my little trick that I did yesterday where I highlighted the lines so I could really see which ones they were talking about. So they're talking about line MN and line OP. Those lines are never going to cross, which make them parallel lines. So I go over to box 3 and I write parallel. P-A-R-A-L-L-E-L. Okay, I also chose number 4. Choose the number that is a multiple of 6 and 4. So when I count by the number 6 and when I count by the number 4, I would be able to get both those answers in one number. So if I count by 6, I can get to 18, but I cannot get to 18 with 4. So that can't be it. I can get to 8 by counting by 4s, but I can't get to 8 by counting by 6s. 16, 4 times 4 will give me 16, but I cannot do that with 8. 30, not 8, I mean 6. 30, if I count by 4, I can't get to 30, but I can with 6. And last but not least, we have 12. Well, 6 times 2 will give me 12, and 4 times 3 will give me 12. I use that process of elimination to determine the multiple. Going on to number 11, we have to determine the difference, which tells me already I'm subtracting. And I am going to be subtracting the longest minus the shortest thumbs in the sample. Well, the longest thumb in the sample is 2.5 inches. And my shortest thumb is 1 inch. I can assume that 1 by itself means 1 with 0 over 2. That might help me solve because they don't have any halves, but it will help me solve 1/2 minus basically blank. So 1/2 minus 0/2 will still give me 1/2. Then I move on to 2 minus 1. 2 minus 1 is 1. So my answer is 1 and 1/2. Going on to number 12, when the numerators are the same, the larger the denominator, the smaller the unit is. Fill in the sign that makes this sentence true. So we talked about this last week. The larger the denominator, the smaller the pieces. So if I have 4/8 and 4/10, I can draw myself a picture so I can visualize this. So I have 2 rectangles of the same size. And I'll make the top one into 8ths. And now I'm going to make the bottom one into 10ths. Right away, I can see my 8ths blocks, even though they're only slightly bigger, are bigger than my 10ths. 4/8 is this amount, and 4/10 is this amount. We can see that 4/8 is larger than 4/10, so I'm going to do the greater than sign. My last problem that I'm going to solve, it says use the fraction model to solve 4 times 2/3. So we have 4 times 2/3, meaning I have 4 sets of thirds. On each set of thirds, I'm going to color in 2 of those 3/3. And the fraction model means that I can go through and count the amount of thirds that are filled in. So I have 1, 2, 3, 4, 5, 6, 7, 8. It has to be thirds on the bottom because that's the unit we're working with. Okay, those are, bless you. Whew. Those are the ones that I did today. If you have any questions that I did not cover, I can go over them this afternoon, or you could even ask during our morning meeting tomorrow, okay? But those were the 5 that I think posed the most challenge on the lesson. Okay, so I'm going to close my Simple Solutions book and ask that you take out your geometry terms page that looks like this. It is in your math folder. Go ahead and pause this video so that it can be found. Now that everybody has their geometry terms paper, I'm going to flip mine over, and I would like for you to copy my first definition. I have what we call a set of parallel lines over here to the side. I drew 2 lines that are never going to touch. They have arrows on both ends of the lines. They could be line segments as well, but in this case, I drew lines. So I have line JK and I have line MN. I'm going to write the definition. Parallel lines are lines that will never intersect. Then I have to write out what that looks like. So just like we learned notation yesterday for line, we're going to write line JK is parallel. We're going to draw 2 lines, almost looks like 2 tally marks. Line JK is parallel to line MN. And I read that like line JK is parallel to line MN. Pause this video to make sure that you have all of what I have written for the definition for parallel lines. Okay, our next definition is perpendicular lines. So I drew basically kind of a line here and a line here that cross, and I put a little box here to indicate that I've made a right angle. So they have to be almost like a perfect T when you draw it. We have perpendicular lines are lines that intersect and create 90-degree angles. We can also create right angles, okay? Then to write it out in notation, I have line PT is perpendicular. The symbol for perpendicular is an upside down T to line RQ. Line PT is perpendicular to line RQ. I would read that as line PT is perpendicular to line RQ. And if you're having a hard time spelling perpendicular, it is PERPENDICULAR. I also have a new anchor chart that is up on my chart paper up at the front of the room underneath the flag with the same exact notation to kind of help you with today's lesson. But keep this paper out on your desk. Pause this video if students still need any more time to copy the two definitions for parallel lines and perpendicular lines. I did want to go over our hand motions really quick. So we've kind of talked about them before. Parallel, so you could do your arms straight like this, bringing them up so they're not touching, or they could go like this. Both of those will symbolize parallel lines. Our perpendicular lines, our motion is kind of crossing it in the front. Okay, so leaving this on your desk so you can see the notation and how you're going to do that in today's lesson. I am going to take out my Eureka math book and we're going to skip a couple lessons and go to lesson 3. I guess skip just one lesson today. So we're going to skip one lesson and head to page 17. We're going to do the problem set for lesson 3. Now I'm going to be walking us through some of this. You're going to have some time to work as well. So we're talking about perpendicular lines. So my symbol again for perpendicular lines is this crossing motion. So I'd like you to take a couple of minutes to look at the top boxes, top objects, I should say, in the first question. Look for examples of what you think are perpendicular lines, and I would like for you to trace them. For instance, if I were to look at, let's say, this brick wall, I see a set of perpendicular lines that goes like this at the bottom. Are there many more examples of perpendicular lines in that brick wall? Yes, there are. But I'd like you to take the next 2 minutes to find as many sets of perpendicular lines as you can. Pause this video so that students can find those perpendicular lines. Now that you've had a couple of minutes to find them, I'm going to go through and look for some examples of my own. Now, every single picture has examples. So even if you don't think that there's an example of perpendicular lines on it, there are. I'm going to go through and look at the more difficult objects. Remember, we're making a 90-degree angle. So if I look here, it might not look like a 90-degree angle, but if I can use my piece of paper that we just used for my definitions, I can see that this corner lines up. The corner of a piece of paper makes a perpendicular or a right angle every time. So I can see that that bottom of this hexagon is actually a right angle. Now, not all hexagons are going to have a right angle. This is just a special hexagon. Also, I can see in this football a set of perpendicular lines. I hope you found in every object at least one set of perpendicular lines. Now, how do you know if two lines are perpendicular? Two lines are perpendicular if they intersect. That's a fancy word for saying cross, and create right angles. Two lines are perpendicular if they intersect and create right angles. In the square and triangular grids below, use the given segments in each grid to draw a segment that is perpendicular using a straight edge. So my straight edge today is just going to be my piece of paper. So I can kind of just do my best to draw some lines that will create perpendicular lines, creating right angles. Maybe on this one, I just go over here. This is just some practice time to make some right angles. Now, Mrs. Pierce did not make a right angle there. She would actually have to move her paper a little bit. And then it looks like a right angle. See, I had to practice and do it again. Going over to the triangular one, this one's a little easier because there's more lines to break up the boxes. Oh, that looks like a right angle. And what if I went like here? Would that make a right angle? Looks like a right angle. Give yourself some time to practice writing some straight lines to make those perpendicular lines, those right angles we're looking for. Okay, on page 18, we're going to turn the page. And on page 18, we're going to use not a right angle template. We're going to use just our piece of paper because we have that perfect corner. We are going to determine which of the following figures have a right angle. Mark each right angle with a small square. For each right angle you find, you have to name the corresponding pair of perpendicular sides. So they first found this right angle. So you have to find as many right angles in the shape before you move on. So they have line segment AB is perpendicular, that upside down T, to line segment BD. I see another one right here. So I would write line segment BD is perpendicular to line segment DC. Now I'm looking at, oh, this one, the two line segments that are involved are DC. Line segment DC is perpendicular to line segment CA. And finally, I have one more. Line segment CA is perpendicular to AB. Now, are all of them going to have right angles? Let's see. So if I use the corner of my paper, that's not a right angle. That's not a right angle. If I turn my book, that one's not a right angle. And I go around the entire shape and I determine that B does not have any right angles. Well, if I see that it has no right angles, I'm going to cross the shape out. I would like you to practice for the next, let's say 10 minutes, not 10 minutes, 5 minutes on this page. I would like you to find as many right angles as you can on this page before we move on. So pause this video for 5 minutes to find as many right angles and label, doing the notation that we did above, all of your perpendicular lines. If you finish that early, you can do 5 and 6, but pause the video. Now that you've paused the video and you've worked on number 4, can you actually turn back to the front of lesson 3, write your name on it, tear out the page. Don't get up and put it in the pink bin yet, just put it over to the side. Mrs. Pierce would like to look at it when she gets back in the classroom. And you're actually going to go on to lesson 4. On lesson 4, we're on page 25. Page 25 for lesson 4. In lesson 4, we're going to be talking about parallel lines, lines that do not touch. So we have some of the same objects, some different objects than we had in the first lesson, but you're going to be finding parallel lines. So for instance, when I'm looking at this brick wall, I can see that this is a parallel line to this line. I would like you to spend the next 2 minutes and find as many parallel lines that you can. Each object has at least one set. So in each object, you should have one set of parallel lines. Pause this video for 2 minutes. Now that it's been 2 minutes, I would like to go over how you would notate some of these parallel lines that are harder to find. So I found a set of parallel lines on this watch. Did you see this set? Or did you see this set? Or this set? You just have to kind of use that keen eye of yours to kind of find these parallel lines. This trapezoid, our parallel lines would be this set, because if I chose this set, they would eventually intersect, which is what we do not want. So how do I know if 2 lines are parallel? Lines are parallel if they never intersect. In the square and triangular grids below, we're going to do the same thing that we did with the perpendicular lines, except now we're finding parallel. So you're going to use your paper again to kind of use it as a straight edge and try to draw some parallel lines. That one looks pretty parallel. It might be easier to draw a set of parallel lines if you draw them closer together. That one might end up crossing eventually. This one's kind of easy because I can use that top line. And then maybe this last one, ooh, that one's kind of hard. But try my best to draw a set of parallel lines. You do that as well before we move on to page 26. On page 26, you're going to, again, do what we did for perpendicular, but our notation and the way that we show parallel lines is different than perpendicular. So you're going to determine which of the following figures have sides that are parallel using a straight edge and the right angle template that you created. We're not using a right angle template, we're using our piece of paper. We're going to circle the letter of the shapes that have at least one pair of parallel sides. You're going to mark each pair of parallel sides with arrowheads. Then identify the parallel sides with a statement modeled after the first one in 4A. So I'm going to finish out 4. We can see these really lightly colored arrows that they have, when we have an arrow like that, that shows us a parallel line. So they tell us that line segment AB is parallel, that's our symbol for parallel, to line segment CD. The other set of parallel lines in this shape are AC, and on my second set, I draw 2 arrowheads. Line segment AC is parallel to line segment BD. So we circle the letter if it has parallel sides. Moving on to B, I see that there's a parallel side here and a parallel side here. So I would note over to the side, line segment HI is parallel to line segment JK. HJ and IK will eventually run into each other and intersect. So those are not parallel sides. I can circle it though, because it is a parallel set of lines on there. For C, do you see any set of parallel sides? Let's see here. Well, there's no parallel line that will go there. These ones intersect, so there are no parallel sides here. So I would just cross off C. I would like you to find as many parallel sides and note them as you can. Notice, remember, you have to find as many on each shape as you can. And for the second set, I put 2 arrows. If there's a third set of lines, I put 3 arrows. If there's a fourth set of lines, I put 4 arrows. So you're going to get another 5 minutes to do number 4 on this. If you have extra time and 5 minutes hasn't gone off yet, then you can go over to the second page. But let's pause the video here. Now that it's been 5 minutes, I'd like you to turn back to the front of the page, write your name on the top of your page, tear out the page. My substitute can obviously come around and help you if you're having difficulty tearing out the page. You're going to take both papers, stack them together, lesson 3 and lesson 4, and you're going to turn them into my pink bin. If you are not quite done with 3 and 4 and we have time left, go ahead and finish lesson 3 and 4, number 4. If you are done, your whole page is finished, turn it into my pink bin. And then you'll go on to Zearn until 10:45. Thanks, guys.